Welcome to this video lectures. Today's topic is electrostatics. We are going to start with this term. Okay, so electrostatics. Basically, it is divided into two kind of a term. One is electric charge and other is test. So electric charge. First, we need to understand this term. We need to define that much of term. What do you mean by electric charge? Okay, so electric charge is the property of a matter that influences electric force, field, and potential, etc. Okay, so basically, electric charge is the property of matter that influences electric force, field, and potential. Okay, and that much term rest you have already discussed in your previous classes. Okay, in mechanics or something like that. Now, the second question that comes in our mind when we know the electric charge is something is a property. So now, from where is this kind of a property, or from where we are going to know about this? So there is a production of charge. How this production can take place is first by friction. When we are going to rub two bodies with each other, we will see that one body will acquire a kind of a charge, another body will acquire another kind of a charge. Okay, namely we are going to say it as one is positive, another one is negative. Second one is by conduction. We are going to produce a charge by the means of a conduction when one charge body, I just remember this term, one charge body is bring to near uncharged body. First it is uncharged. When we are going to just touch it, the similar kind nature of a charge is going to transfer from this body to that much of body. So this time both of them will acquire same kind of a charge. Okay, and third term is by induction we can also produce a charge. By induction we need to understand this term that there is no kind of physical contact between these two bodies. Okay, one is, suppose one is a charge body, this time it is positive. If it bring near to a uncharged body, you bring near to an uncharged body, so what happens with this positive nature of charge, they are going to be attract the negative charge present on this uncharged body, as a uncharged body will have a positive and a negative, both kind of a charges. We know all the bodies are made up of a matter. Okay, and matter are made up of atoms. Atom has a positive and a negative. So what exactly what happened over there is there is a little shift of the charges. The negative sides of the charges will come to this side, and the positive side will go to that much of side. Okay, so with this, what will happen? That this body will acquire a different nature of a charge rather than positive. Okay, so we have the two kinds of charges. One is positive, another is negative. Okay, so we need to understand this concept that whenever we are going to discuss about a body, okay, it has a positive or a negative charge. If their amount is same, positive and negative, we are going to say it as a body, or simply a body that has a neutral charge. But what will happen when we are going to term with the term charge body? Okay, so when we are going to say yes, term like charge body, we need to understand that kind of concept that there should be excess of charge. Left the topic on charge and charge bodies. So now we need to first understand what do you mean by a uncharged body. Okay, so uncharged bodies, and simply we understand it by a concept of isolated atom, as it has an equal number of proton and a electron. That's why we are going to say it as a neutron, because it has an equal number of proton and neutron. But when we are going to come in a term of charge body, what will happen? That there should be an excess of positive or a deficit of negative charge, that we are going to term as positively charged body. But when there is excess of negative charge and a deficit of positive charge, we are going to term it as negative charge. Okay, so that is the concept that we need to. Next topic of this video is properties of an electric charge. So the properties of electric charge, they are the fundamental properties that we already know. Like charges repel each other, unlike charges attract each other. If they are two positive charges, they are going to be repel each other. If they are two negative charges, they are going to repel each other. Or if there is one positive and another is negative, they are going to attract each other. Now, then we are come to the point that charge is conserved. So with this, we are going to discuss more. So charge is conserved. That simply means we are going to follow conservation of charge. The conservation of charge is similar to the conservation of energy principle. That charge can neither be created nor be destroyed of an isolated system. Okay, if there is a system, we are not going to be create, or we are not going to be destroy that charge, and the total charge of a universe is remain conserved. Okay, so charge of a universe is remain conserved. Now second is charge is quantized. With this quantized meaning, we are going to be something like integral multiple. With that integral multiple is, if there is a charge on a body resides, or there is a transfer of charge from one body to another happens, it happens in such a form that the net transfer of a charge from one body to another is by the integral multiple of a small amount of charge that we can consider as electron. Okay, because there is no such kind of transfer of proton charges. So quantization of charges, the transfer of a small amount of charge in an integral form. Okay, that is called quantization of. That's why we are going to start with a, we have a formula q equal to n. With this term, that means the q is a net charge on a body, or net charge going to transfer from one body to another. Okay, so that net charge is a number. That number should be an integer. Okay, plus or minus sign represent that it should be a positive or a negative, mm, by the nature of the charge. Okay, and this one is a charge of an electron. Okay, so what if someone is going to ask you a question that how many charges in 1 coulomb, then your answer should be, it may come from this formula. If you have 1 coulomb of charge, you know the charge of an electron, that is 1.6 into 10 to the power minus 19 coulomb. You just divide this factor, you will get a value that you need to calculate, and just, after calculating these, you just get your answer. It is about, we can say, 6.25 10 to the power 18 electron. That much of charge is in a 1 coulomb of a charge. So coulomb is a bigger unit. Okay, so with this, we also know about the unit of a charge is, that is coulomb. Okay, now second is charge is additive. Okay, so addition of charge, that explain that the charge is going to be added by a means of scalar addition. Okay, what do you mean by scalar addition? That you have done in your previous classes, like the algebraic addition. 1 plus 1 is equal to 2, 2 plus 2 is equal to 4, 2 plus 3 equal to 5. This is the, that we call a scalar addition. Okay, so with this, we charge is additive nature, we are going to define charge as a scalar quantity. Now second is charge is invariant. That means the charge at rest is equal to charge at motion, or we simply understand the concept that the charge is does not depend upon the velocity of the body.